When I'm integrating, I'm first going to look for standard integrals. And I'm going to ask myself, is secant squared the derivative of any functions I know? And the answer would be yes. The secant squared is a derivative of tan. That means that the integral of secant squared, or the antiderivative of secant squared, must be tan. So that's what I'm going to do here. I'm going to anti-differentiate this into a tan function. Because there is an embedded function, it's an embedded linear function, I just need to divide by the coefficient 3, because that would have been multiplied by 3 when I differentiated. Now, because this is an indefinite integral, make sure you don't forget the plus c. For this one here, this is not a standard integral. Even if I kind of group it together, I have tan and 1 over sine to the power 4. So this is not a standard integral. So I should think, is there an algebraic rearrangement? Doesn't look like it. I need to think substitution first. So if I think of substitution, I should really think of what is the embedded function in here. In this case, it's sine. And then I need to then ask, if I choose u, sine is my u value, does the derivative of sine account for what's left over on the outside? So in this case, it does, because if I embed the u into the sine, the leftover term shows up in my derivative. So I can use substitution to integrate this. So I'm going to end up with 1 over u to the power 5. So I replace that sine with u. Then I can replace the cos dx by du. And now I have a function in terms of u, in terms of du, with a variable u. So I can just anti-differentiate this as I normally would. So this becomes, that's power negative 5. So I'm going to increase the power by 1. So it becomes u to the power negative 4. And I'm going to divide by negative 4. And I'm going to make sure I have a plus c in here. Now this is not a u function. I really want to express this in terms of x's. So I'm going to rewrite this. So negative 1 over 4. And instead of u in the denominator, I'm going to replace that u to the power 4. I'm going to replace it with what I substituted u for, which was sine x. So there's my antiderivative. I need to make, since it's an indefinite integral, I need to make sure I have a plus c here. And again, I could check these by just differentiating this, and I will see that when I differentiate this as a power times negative 4 cancels the negative 1/4. I end up with a power negative 5, and then I times it by the inside function's derivative of sine is cos. That will generate my cos that I had to start with. So in C, this is not a standard integral. I don't know if I can rearrange this very well. Okay, what I might want to do is split this up though. So splitting this up is going to do this. So I'm going to end up with log 2x all squared over x. And I'm just going to do that as separate integral. Actually, I can just leave it at one integral. And I can integrate these two parts separately from each other. And I know that my 1 over x is actually a log function. So I'm going to maybe just do this dx and minus 1 over x dx. And I know I can integrate that part. I can't integrate this part, the ln 2x squared over x. So I need to think of some strategies. Can I do a substitution? Well, if I'm going to do a substitution, there's my embedded function. So I'm going to let u equal log 2x. Does my derivative account for the leftover term? So make sure I use chain rule. Does it account for the leftover term in this expression? So does the du take care of the x dx over x? There's my dx over x. Yeah, this I can replace all parts of this then. So then my integral looks like this. It's going to be u squared. So I'm going to put my u in there. And then I'm going to get rid of that dx divided by x with a du. And I can integrate that in terms of u. I can integrate this in terms of x. This is going to end up being log x. And again, don't forget the plus c. Integrating this becomes u cubed. It becomes u cubed divided by 3 minus log x plus c. That u cubed is really not a u, but it is really a log 2x. So now I have brought it back to brought it back in terms of my x's.